Hey folks, in this video we're going to take a look at creating a program that uses threads that access global memory. This is going to be, I think, at the start of a long conversation, right? So the word memory here is really key. So let me start with a quick little diagram. So we have basically, potentially a process that's running, right? Maybe something like this. We'll try to diagram that, pretend that's straight. And now we create threads, right? And so if I look at my previous program, or even just think about it, right? Basically the way it looks is there's a program running, a thread does something, a thread does something, right? Something like this, right? So these little lines represent a thread kind of coming out from the side. What we also need to start thinking about is basically, where are they pulling information from? And so it's a little bit hard to diagram, but the thought is this, right? I have basically, right, a process that is running, and what I'm going to have is it basically owning memory, and I'm going to give it probably something that looks like an array, right? With different pieces of data in there, right? And then I have my threads that are running within that process. Well, what we're basically going to have in global memory is threads will have the ability to access this global memory, right? So the global memory, right, is really owned by the main process, but then these other different threads that are running, they'll have the ability to go and manipulate or view this memory as well. So this is kind of how our picture is going to look. And I think actually, yeah, in the end, and then what I'm going to end up doing is I'm going to have 3 threads, right? So it'll actually be a little bit more complicated than this. Well, let's add a lot of third thread in there, trying to do this. Basically, right, we'll have this thread that goes and, has access as well, right? And so basically, right, they're all going to be using that kind of same memory, right? Same shared memory. And this is maybe a little bit of a problem in the future. We're not going to worry about too much for now, but for now, we'll just think of the following thought. If I had 3 things running, or however many number of things running, and they all want to use the same data, how do they take turns, right? Because that data can only exist in one CPU cache at a time, right? There can only be one copy out there. And so if I only have one copy, yeah, it'll work, but they're going to somehow be forced to take turns, right? It's what they call a cache locality issue. And so we want, ideally, some way around that. So we'll try to fix it later on, but for now, just be aware of that, right? For now, I just want to focus on the fact that we have global data, meaning it's owned by the process, and all the different threads that are out there are going to be using it. Okay, let's jump back over to our program. Really quick, I think I'm going to do a little bit of refactoring. Let me grab this code here, and I'm going to actually put this into like another function. So we're going to call this, I don't know, this is the stuff from last time, right? Do I want to call this demo different tasks? That was kind of what we did last time. So we'll call it something like that. Let's move that over there. All right, we may need to copy paste from that later. For now, I'm not going to worry about too much. And then let me I have some comments over here in a text box I'm copying over because I just want to make sure that I'm keeping on track with what I'm supposed to be doing. So we're going to, like I said, work with a global memory here, right? We're going to work with an array, and we're going to basically display the contents of it. That's going to be our plan. Okay, so what do we do? Well, first of all, right, let me just think of what we're going to do. We want to display an array. I'm just going to use an array of points because we've used point2d before, so it's kind of familiar. It's also something that's a little bit more complicated, right? Just an integer, right? So I'll do an array of points, and we'll try to print that out, right? Before, right, over in this code, it was sort of baked in, right? We didn't need any other data. We just knew immediately what to display, right? So we're going to do things a little bit differently here. So let me quickly implement a struct point2d. So we're going to do something like this, and then let's see, I'll just put an x and a y in there, and I think we should be okay there. Okay, so I have my struct there. So I'm going to create an array. I think I'm probably going to need to use the size of the array in a couple different places. So I'm actually going to use a define here, right? So I'm going to do a define, and we're going to basically tell it define. Let's see how many. Yeah, so we're going to do 3 threads here. We're going to do 3 threads here. There's not any particular reason other than the fact that like that'll fit in the console window and it won't be too messy. So something like this, right? So define, and then I'm just going to call this like, I don't know, global thread count. Thread count 3. All right. And then of course I need to actually create my array, right? So my point2d array will be coming over here. We'll just call this global data, and we'll make it the same size as the variable there. All right, so this is my data. So I need to do a couple things here. I need to populate the data, and then I need to create my threaded program that goes and displays it index by index, right? And our goal here, right, is that basically each of the threads sees that different input. And actually what will happen even is that each particular thread will be told, print out, whatever's here. or here, or here, right? They'll be told to print out the individual parts of it. Okay, so let's think. I guess let's start with the actual main program here that has the threads in there. So we're gonna of course have our pthread_t, right? So we need a place that basically that knows about all the different threads that are out there. I want to print out every space, each space in this array with a different thread. So basically I'm going to have to create an array here of this particular size, right? So now I have basically a thread ID variable for every single thread that's going to be running. Okay, so that seems like a reasonable step. Okay, let's see. We're also going to need to basically create all these different threads, right? So here, right, because we have more of them, we're going to use a for loop, right? So basically what I want to do is I want to say, okay, for each of these three, do a thread create, point it at the different TIDs that are available. Okay, so something like this. We'll go from 0, well, I equals 0, and then just basically I less than global thread count, and I plus plus. Should be good there. And then in here, right, this is where we want to actually create our threads, right? And so what we're going to do here is we're going to use that array that we just created, right? And so we're going to say address of, right? Because it always wants the address of the TID array of, you know, I think it's I, right? There we go, I. So basically we're saying this is a particular TID that I want you to use for the thread you're creating right now, okay? And so we'll use that. We won't use anything special for the attributes. I'll just put null there again. And then we're going to have some sort of a function, right, that we'll use to display everything. So I'll just leave that kind of as a placeholder for now. And then what I want to do, right, is I somehow have the option here basically to give data to my thread, right? And what I want to do, right, is kind of give them a different part of the array to work on, okay? So let's just leave that kind of as a to-do for a second there, and we'll come back to it, right? So I need to figure out, you know, what to run, what data to pass, right? Those are the things I need to figure out, right? But this is pretty simple for what we need to do so far. Let's continue on here. I'm creating threads. Because I'm creating threads, I need to join them. Otherwise, I don't have any guarantee that they'll actually complete before my program terminates, okay? So I'm going to go ahead and do my joins over here. So I'll do a pthread join, and this is going to look the same as kind of what we've done in the past, right? So I'll pass it the TID for that particular index, and then I'm not going to really care about the output, okay? Because I just really want to display the contents of this array, okay? And I still have to set up the contents of it as well, right? I want to display it, right? But I also need to set up so it's something other than just garbage, right? So we'll do a little bit of work there too. Okay, so something like this, right? So you can kind of see that where our programs are going to have this general flow of, let's create a thread, point it at a function, possibly give it data, and then return from it, right? Or wait for it to finish. And then maybe we have some result, maybe we don't. Note that these two loops have to be separate. Otherwise, we do a create, wait for a thread to finish with a join, and then create another one, right? We want to basically to create threads in parallel, right? So this picture over here we drew, this is parallel, right? So you see them basically being active at the same time. There would be another possible picture out there, right, that looks like the following, which is basically no good, right? So if I do things differently, right, I could basically have this, right? So this is me in my syntax trying to indicate basically that there's one process running and you create one thread at a time, and they're basically in sequence, right? This is not a high degree of parallelism. What I want is I want them all to be running at the same time, right? And so if you put basically these two things back to back, create and join back to back over here, then, right, you get this pattern, right? You get only the ability to do one at a time. Really what you want to do is you want to create them all and then wait on them all, right? That's what this diagram here is indicating, and that's what we want in our code, because then you know they're going to be running in parallel as much as possible. Okay, so that little discussion there, hopefully you guys remember it is very important. Otherwise, you can write all sorts of thread code that actually doesn't give you any sort of speed up, which is definitely not an ideal thing. Okay, so let's see. Let me go ahead and set up my data, and I'm just going to put in some junk. I don't really care too much what it is. So let's loop over, I guess every index, right? So I want to go my indexes. Let me just fill them out. So global data of I. And then I don't know, we'll just go like x equal, we'll just put in like I plus 1, right? So it's shifted a little bit from its index, right? It's like that. And then we'll do the same thing for y. So if I do this right, basically my memory will somehow look like, well, I didn't leave myself a lot of space there, did I? What this will somehow look like eventually is this will be something like, where's my pen? 112233, right? Some really basic pattern like that, right? And my hope is that basically threads will print out one of these, right? They'll print out 11 or 22 or 33, depending on which thread it is. Okay, so that's what's going to be stored in our global data, which is being set up over in our main. Okay, so it looks like that data is pretty good. Let's now think about our actual threaded function, and we'll start to outline it. Has to again be the void return, right? That's not something we can really change. We'll call it what? Display text global. That sounds reasonable to me. And we need to, of course, have the void star as the argument as well, because it's the runner function. So of course the bit of code, right, that we basically run in our thread. And I know, right, we need to have our pthread exit as well. Don't need any data back from it. We're just trying to display things. So it's starting to look like this. Now I can go back to my pthread create. I kind of know that this is going to be what I call with it. Okay. So now I know that this is going to be what's happening in my threads. If I run this, you know what? Let's do that. Let's run this real quick. If I run this, it should run. It won't give me any output, but it should at least like compile and not crash. Okay, it did nothing. That was a good sign, right? It didn't crash. It didn't refuse to compile. So right now, right, it's like we're spawning the different threads, right? We're finishing them, but we don't actually do anything in them. Okay, so I think we're okay there. So I have to kind of figure out how I'm going to set this up. Now I know, right, that my data looks like this. So maybe if I want the threads to print that out independently, I want to give each thread the address of a particular index into the array, right? If I do that, then basically each of those, right, will be able to process a different index. So I'll just update my picture a little bit here, I think. It'll probably end up looking like that, right, where every thread looks at a different index in the array. So what I can do is I can basically use this argument here to pass a pointer to a particular place that I want to display in that array. So it's like I'm going to tell it, this is the area you're working on. So global data of, and I'll give it basically I, right? So the first thread, right, thread 0, will print out the thing that's stored in index 0, right, which should be 1 by 1, right? Thread 2 will get 2 by 2, thread 3 will get 3 by 3, okay? So again, the idea is I'm going to give it the address of the data that I want that particular thread to use, right? The threads won't be able to see that entire array. They only get to see what I'm giving them, which is a pointer to a particular index, right? So they only, as far as they know, there's only one piece of data out there. Okay, so at this point, we basically have each thread knowing about a piece of data. So now we got to display it. First thing we have to do is going to be pretty typical of runner functions, in that we're going to need to basically convert our data parameter, which is a void star, to something that's actually useful for us, which would be a point2d pointer, right? I need to actually have my type, not the generic one, right? It's just void star here because like there's no way for the C language to know what type you have in your program. So like, let's be generic. The only generic thing we really have is void star. So that's why those are both a void star, because they don't really know what you're doing. Okay, so let's create a new variable here, right? We'll just call this something like point. And what I'm going to do is basically make this the data value, right? I will have to add the cast there, right? So I need to cast it. It's initially a void star, and we'll say, okay, you know what? It's fine. We'll treat it as a struct point2d. So let's basically cast my data input to this particular struct and then save it into point. Okay. Now we can do something like this. Now we can basically do a print, right? So we can do something like point of, maybe it'll just do it like, just order it a little bit. Something like this. And then, right, we'll pass it some data, right? So I'll go point. This is a pointer, so I need an arrow, X, right? And then point Y. All right, so that should basically print our data inside. So let's give it a run. All right, 3, 2, 1. So it looks like it's all working, right? So you can notice, right, that this function here only has one print statement. So the only way for us to get 3 print statements is if it ran 3 times, right? So basically we know that 3 threads are running. Let me run it again real quick. I'm curious if I get a different output. Okay, 2, 1, 3, right? So you can already start to see that there's a potential different output depending on when we run these things, right? They may basically get through in a different order. Okay, so that's our example here for using global memory. Just to reiterate really quick, right? We basically, we create and join threads. We always do that. And then our idea here was there's going to be some big piece of data outside that's global. And here, right, it was an array of structs. And so what we did is basically we said, okay, let's give everybody a pointer to part of it, right? Because then, right, they basically get those little arrows, right? We get this picture over here, right? There's a blue arrow from each thread to each index in the data. We get that, right? And so now when I go to print, I have access to that information, so I can display it. I have access to that, so I can display it. I have access to that, so I can display it. Okay. So that's our basic form here. Now, before we end this video, I do want to talk a little bit about how this works with dynamic allocations, because it will be a little bit different, and I do want to show you guys basically how it looks. We're not going to spend as much time on it because we're not going to need to do as much, but I do want to show you guys how this looks with dynamic allocation, mainly so that the pointers will kind of make a little bit more sense later on. So let me first grab this. I'm going to do this thing I did before where I basically created a function, right, that has all of that test code in there. So let me do something like this. Okay, that's been moved out. So I have those three. Okay. So this over here, right, is a, well, I was going to say a static allocation, right? It's basically something that's going to be alive for the lifetime of the program, right? So this is the global. It's not on the stack. It's not in malloc. It's basically just going to be always around for the lifetime of a program, and so that's nice for threads because when they want to use it, they can know that it has to be there, right? That's a great thing. But sometimes, right, we're basically forced to use dynamic memory allocation. Things might look a little bit different. Okay, so we're going to try and do that instead, which is going to be, I mean, it won't be super different, but it is more complicated, and also you will probably need to do it at some point. This is sort of the easiest case for shared data. And actually, I'll give you guys a hint, right? The reason why we want to even talk about dynamic memory or start to talk about dynamic memory is that in the future, we're going to have basically different pictures. Well, I got pictures look like this. Let me quickly edit. You can see all my mad paint skills here. Trying to draw. This is actually going to be nice. So the picture on the right is better than the picture on the left, because what it's showing is each thread has independent memory, which means rather than fighting over one big piece, they have their own thing to work with. So this is going to be very, very efficient versus this, right? This may not have much speed up at all. This over here definitely will, because each thread can work alone. It doesn't need to get a hold of that big piece of data and ask other threads to basically play nice, right? Because your system doesn't really understand that they're working independent bases. All it knows is that they want to access the same rough region, and it doesn't want them to interfere. So it'll make them basically act one at a time. If you break into pieces, though, that's not an issue. Okay, so what happens if we do global? We do global dynamic memory. First thing I'm going to do here, I'm going to do a couple things here. I have my little text that I'm going to paste in really quick. This is just me again trying to keep on topic. What I'm going to call this basically is I'm going to make another variable. It's going to be global data dynamic, right? So in this case, right, I'm going to have a struct 2D, point 2D, but now it's going to be a pointer, right? I mean, technically it was array before, so it's kind of a pointer, but now you can really see it is going to be a pointer, right? And it's going to be a pointer to dynamic memory. So also like this, right? So I'll have basically my dynamic memory allocation going on there. Let's grab this over here. So some of this will stay the same. Okay. So let me try to decide. So I want to emphasize that this dynamic, so I'm going to get rid of the constant. We're going to do the following. And you might wonder why bother to change this, but the thing is that, like, basically C is very happy if you have a constant. It's a lot less happy if you have a variable somewhere, right? And so I want to use a variable just to indicate the fact that it's sort of like it's just in time, right? If you wanted to, you could add a scanf here and change the thread count, and it would give you a different output, right? And it wouldn't just crash and burn. I mean, it might crash and burn a little bit, but in principle, it is set up to do. Actually, no, I'll take that back. It'll actually work if I do a different thread count. It'll eventually work. And that's basically what I want to emphasize is it's sort of dynamic, right? You could do a scanf for how many entries, and you could put it in, and it would run and work and show you the proper outputs. So if I do a separate variable, it's kind of easier to see that. Okay, so we're going to use that variable to create our number of threads. We're going to need to do a couple of things here. First thing, just to kind of be, I don't know, fancy, is I'm going to change this to be a dynamic memory allocation, right? So the TIDS line, let's make that dynamic. So let's see, we'll need the cast, right? That's always the first thing we need to have. And then there'll be a malloc, right? Malloc. Am I not typing very well? No, it's not that. It's that I don't have a standard library include. I need to have include stdlib to do a malloc. I thought it came in through stdio, but I guess not. Okay. So I'm basically going to allocate memory for these different thread IDs. Okay. So in this case, I'm going to make a call the size of, and basically I'll just tell size of, oh, hey, give me the size of p thread t. And then because I know there's thread count many of them, I'll just multiply by thread count. So something like that. Okay, so I have dynamic memory for my TIDs. That should be fine. I think I can leave the rest of that alone. And we actually already figured out that stuff, didn't we? So we can remove those comments. Okay, so my main thing here is actually that I need to switch right to using this global memory. So I'm going to replace these 3 variables here. And now I need to actually malloc it, right? So I'm going to malloc this. So I'm going to do a malloc. The cast in a second. The malloc basically, right, is going to be size of the struct point2d, right? So those are the things that are going to be inside of it. And then I'll again multiply by times thread count because that's how many of them I have. And then last thing is we'll of course throw a cast in front of it, right? So something like this. Forgot my semicolon. There we go. So this should basically allocate memory for 3 different point2ds that will be saved as kind of as an address into the global dynamic memory, right? Okay, and I think this might be it. Let me look at this. So that's set up. Okay, we're passing it. And I know I'm still using that bracket thing, right? So the bracket thing is kind of just because even though this isn't really an array, I mean, C is like arrays, pointers, same thing. It can kind of see that the type of it is a point2d pointer, and so it kind of understands like, oh, this is where the first one's going to be. This is where the second one is. This is where the third one is. Okay. Okay, I'm gonna go ahead and run this. I'm actually not sure if it'll work or not. I think that I did everything right, but you never know with dynamic memory allocation. It actually worked. Okay. When I was first practicing this for this video, it did not work on the first try. Okay. So that's our memory there, but now we've done it basically with a dynamic approach, right? And so it's not a whole lot different, right? You guys saw this stuff up here changed. Most of this down here, right, can just all stay the same. But it is kind of, like I said, more useful to us, right? Because again, we had this discussion of this causes everything to wait on getting the same piece of data, even if it's on different CPUs or because it's on different CPUs. This means that basically your data can go to different places, right? So you can have different CPU cores that have their own piece and they work exclusively on that, right? Versus here, they might be trying to run on different cores, but they all fight over the same thing. Okay, so that's it for this video. Hopefully you get a little bit of better sense about how to get access to data inside of a thread program. So I'll see you guys later on.